Hello, my name is John Newman, and this is The Spread of Behavior in an Online Social Network Experiment. The author is Damon Santola, and this is presented by John Newman. How do social networks affect the spread of behavior? As we know, many behaviors spread through simple social contact. But the question this paper is asking is about the network structure. The network structure of who is connected to whom can critically affect the extent to which a behavior diffuses across the population. And there's two competing hypotheses for this. There is the strength of the weak, the simple contagion, and then there's the complex contagion, which doesn't have as cool of a name as the strength of the weak. Some preliminary knowledge, some interpersonal ties, just a quick refresher. Interpersonal ties are defined as information-carrying connections between people, and there's three types. There's strong, directly linked, such as you and your best friend. There's weak, which is basically you have two best friends, and those best friends through you share what's known as a weak tie, and this will be shown in a picture later on. And then you have the absent tie, which is basically you nod to an individual on the street, you have made a tie with him, but it's really not there. Yes, you share the common street, and yes, you share a common, you're both walking and looking at each other, but there is really no tie. And here's an example of the strong and weak ties. You with your best friend, a strong tie, and then you with your two best friends, they share what's a weak tie. This can be seen with maybe on Facebook, you resharing one of your friend's posts, this information gets traveled to your other friend, right, who then sees this information and maybe says, oh, I enjoy what this guy's posting, and accepts him and generates this weak tie, this common interest. So strength of the weak basically predicts that with long ties, social behavior will spread farther and more quickly than in networks which are highly clustered. And a long tie is basically these ties that allow information to travel extremely far. So you're located in Florida, and you have a friend in Florida with you, and you reshare your friend's post with your friend in California sees it. This information now has traveled extremely far, extremely fast, and it allows the spread of ideas. And then small world is basically strangers are linked by a short chain of acquaintances. This can kind of be seen with like the 6 degrees of separation, 6 degrees of Kevin Bacon. You're only 6 steps away from knowing Kevin Bacon or being best friends with Kevin Bacon. And the strength of the weak says basically a single contact with an infected individual is usually sufficient to transmit the behavior. And this can be seen as you resharing the post, and your friend who is in California sees it. Now that information has basically infected him, supposedly, but we'll see what the other side of this is. The complex contagion. This says that you usually need multiple sources of infection to adopt a behavior, right? And this is through basically cluster networks, they say, that have more redundant ties, and these provide social reinforcement for adoption, and this will better promote the diffusion of behaviors across large populations, right? And I have two pictures over here which show the demonstration of redundant and non-redundant ties. A is considered to have non-redundant ties because each of these 3 cliques are a different group, and they all provide different information to A. And maybe the same information, but it's a different a different group presenting it, so it may have more influence, and this would be considered the complex contagion, where you need multiple sources all sharing a similar idea or behavior in order for A to get infected, right? Whereas B is in what's a redundant tie situation. These 3, this clique right here, these 3 nodes, all share information across each other. So they're like best friends, they always go and they always sign up, they always see the same movie, and they always do everything together. So this states that basically there's less value to that because this group is already considered basically like one node. So the experiment. A quote from him is, "I studied the spread of health behavior through a network-embedded population by creating an internet-based health community," which is a forum. In this experiment, he made a forum, and it contains 1,528 participants recruited from health interest worldwide websites. Each participant created an anonymous online profile, which consists of an avatar, username, a set of interests, and then they were then matched with other participants, referred to as health buddies, and as members of this online health community. The experimental restrictions. Participants could not contact their health buddies directly, but they could receive emails from the study informing them of their health buddies' activities. Right? This is to preserve, the anonymous aspect and to prevent people from trying to identify friends and getting influenced by it. We're trying to eliminate social tie interactions. And so he blinded the identifiers that people used. The contagion. The participants made decisions about whether or not to adopt a health-based behavior based on the adoption patterns of their health buddies. So based off the node you're set at with your degree, based off those nodes that are attached to you, those are the only messages you got to see. You didn't get to see what everybody else in the network was doing. You just got to see what your immediate proximity was doing, what your health buddies were doing, right? And the health behavior used for this study was the decision to register for an internet-based health forum, which offered access and rating tools for online health resources. To isolate this variable, the health forum was not known or accessible to anyone except participants in the experiment, and the only encouragement to join was from the users in the study. So there is no, outside activity, no advertising, no cost, no, celebrity endorsement. It just was all, a very isolated experiment. Participants arriving to Participants arriving to the study were randomly assigned to one of two experimental conditions, a clustered lattice network and a random network, which I will show later. These were distinguished only by the topological structure of the social networks, which you will see in the next slide. A clustered lattice network has a high level of clustering created by the redundant ties, as we went over earlier, that linked each node's neighbors to one another. As I showed in the picture earlier, you can see that this is going to look like that B node picture where that was like click of three. They're all together, all sharing everything. And then the random network. The rewiring the clustered lattice network via permutation algorithm based on the small world network model. Each node maintained the exact same number of neighbors. This is to preserve the comparison, right? But it reduced the clustering in the network and it eliminated redundant ties within and between neighbors. And here's a picture of that. You can see left is clustered. You can see this is a highly concentrated group, right? And right is random. They're all spread apart, right? And the redundant ties were eliminated. And now the black node is the focal point. This would be the user, right? And these are his health buddies over here. In the cluster lattice network, they shared neighbors, whereas in the random network, they do not, right? And white are individuals not connected to the focal point. These are the people that you don't see the information, you don't see anything. You only see whether or not these guys have joined the health forum, right? The setup. Each participant was randomly assigned to occupy a single node in one network, the black node. The immediately adjacent nodes in the network neighbors, constituted a participant's health buddies, the red nodes. Each node in a social network had an identical number of neighbors as the other nodes in the network, and participants could only see the immediate neighbors to who they were connected. This is what I was just saying. The only difference between the conditions was the pattern of connectedness of the social networks in which the participants were embedded. This is the topological structure. It's, we have the redundant ties versus the non-redundant. Right? So why did he do an experimental network test versus why didn't he just go to Facebook or health forums and get the users' information, get that data and see how users were interacting and how they were being infected and how the spread of behavior happened? Well, there's a lot of observational errors that can occur and a lot of outside influence. So some of these outside influences are non-network factors, are advertising, availability, and costs. Additionally, when you're on the network, the health forum, right, you have the possibility for social influence, right, such as the possibility for social ties to change and affect the network structure and the dynamics of diffusion, right? Additionally, with this experiment set up, right? With an observational case, it's a one-time occurrence. It just happened and that's it. You gotta hope for the next health situation, the next thing, right? We couldn't repeat them trying to join the same form over and over again. But with this process, it can be observed multiple times, which allows us to run the stochastic process for individual adoption, right? And ultimately, all of these points helps us isolate the effects of the network topology. So here's some of the trials, right? The cluster lattice network is the solid black circles, as seen here, and the random network is the open triangles, right? There is 6 independent trials, and there's only a slight change in the variables used, right? We had nodes of 98 in A with a degree of 6. Then we increased the nodes for B through D, which we increased them to 128. Then in E and F, we increased the nodes to 144 with a degree of 8. Right, and as you can see, the degree of 8 here has resulted in a higher adoption early on, right? This is because you have more people around you, and this can be expected because the more people that are joining something, that peer pressure kind of kicks in. And oh, well, my health buddies everybody's joining this forum, I should join this forum. Not saying that you should, but that is what the science shows. Additionally, we can see that in A and B, we kind of have these little flat lines right here. So, there's a high rate of adoption, and then it kind of tapers off, but then it seems like it picks up over here, and same with this one, right? So, the other thing for the measurements, we can see the success of diffusion was measured by the fraction of the total network that adopted the behavior. So this is the fraction adopted, right? And after 14 days, we can kind of say that roughly 55% of the network adopted the behavior, right? And the cluster lattice, right? And roughly 40% adopted it in the random network, which shows that the redundant ties actually performs better in this case for getting a behavior to spread through a network. And in all cases, that's actually true. The random network without redundant ties didn't work, right? So that's stating didn't work as well as the cluster lattice network. And that's stating basically that redundant ties, the same information from a solid group is better in this case than getting it from independent sources. The results. The network structure had a significant effect on the dynamics of behavioral diffusion, which was proven in the previous slides. The topologies with greater clustering and a larger diameter were much more effective for spreading behavior, right, as we saw with the previous slides. On average, the behavior reached 53.77% of the cluster networks, whereas only roughly 40% of the population adopted in the random networks. Behavior also diffused more quickly. Cluster was 4 times faster than random. The experimental findings were qualitatively the same across the different networks and neighborhood sizes. However, networks with a greater degree, z equals 8, performed better than those with a lower degree, as mentioned earlier. Results continued. This is just a quick statement on that redundant signals significantly increase the likelihood of adoption, right? Basically, with more 2 signals, there is a greater chance for a return visit, and with 4 signals, you can see that basically there's like maybe a 5% chance, or there's at 4 returns, there is basically like a 5% chance they would return 4 times with 2 signals, because this is a cumulative distribution. So with 1 signal here, we have roughly the 15% as in all of them, and with 3 signals, the chance of return was roughly 20% for 1 return, and like 10% at 2 returns. And we can see with 5 or more signals of from multiple health buddies, joining the forum and stuff, the chance for return was greatly increased. You can see here that at 5 signals total, that there was actually roughly a 5% chance for a 5th return visit to the health forum. So what can you get from this research? Public health interventions aimed at the spread of new health behaviors, for instance, improved diet, regular exercise, condom use, or needle exchange, may do better to target clustered residential networks rather than the casual contact networks. Not only is individual adoption improved by reinforcing signals that come from clustered social ties, but this individual level effect also translates into a system level phenomenon, whereby large scale diffusion can reach more people and spread more quickly in clustered networks than in random networks. Any questions? And then here's some of the sources. Whoops. I'll bring it back. Thank you for your time.